All right, so hi everybody. I'm Sarah. I'll be presenting for today's topic. So we're doing robot construction. Hopefully you're in the right place. Um, I'll be admitting people as we go in case there's other people joining us. If ever you guys have any questions, feel free to just ask them in the chat. And the moment I see them, I'll answer your questions as we go. So if you have anything, you don't need to wait till the end. If it is something I'll end up covering afterwards, then we'll go over it anyway. So don't worry about that. So does anybody have any quick questions before we start about what we're going to be covering or anything like that? I'm going to take that as a no. All right. So let's see if this works. So the first thing with any project is you definitely need to have preparation and communication. So the first thing is always establish a practical communication strategy. So you need to have something that your entire team can post their announcements on, their updates and everything. So just a general communication channel. One thing I find works really well for that is things like a Facebook group, or like a group chat can work, but things get lost too easily, especially when people start to talk to each other. So something more that has like a board on it. If you have a shared calendar, that can work too, but somewhere where you can really put the big bullet points. Having a plan of action. So that's where you'd probably want to have like a shared calendar, either a physical copy that's in your workspace, but especially now with COVID and everything, sometimes having a remote option is a lot better. And that also allows people who aren't necessarily on site to see the updates. If you have to move up a deadline, move back a deadline, if something changes, then they can see it in real time. So creating a shared calendar, I find works really well. And having something like a Google Drive or a shared workspace on Microsoft can help with all of the diagrams that you're going to be using. So if you do have design plans, it's always good to draw things out. If you need to take notes of things, put them into a drive where everyone has access. That way there's no miscommunication of, okay, well, who had this document or who had that one, or, who knows how we're building this. That way everything is in one place and everyone has access all of the time. The second thing, and it's something that's often overlooked, is just determining a schedule. And it doesn't have to have exact dates, but just kind of estimating how much time each part of your robot is going to take, but also assigning someone who's responsible for it. So of course, we work as a team. Everyone should be a part of the whole process, but always having one go-to person who kind of organizes specific steps is a good thing to do. That way they can delegate a little bit easier. And it's not like the bystander effect that often ends up happening, where if nobody is in charge, then no one will take charge and then nothing gets done. So if you have a team captain and they're able to say, okay, well, for the dropper, I need this person to be the main person to take charge of it. Anyone who wants to take part in building the dropper, go see them and they'll give you things to do. If you want to be part of the drivetrain team, the programming team, etc., just having a go-to person that doesn't have to be a captain, but just someone who is the head of the project and is the one organizing the points and making sure everything is being completed on a reasonable deadline or a reasonable timetable. That's always the best practice, to make sure that everything happens on a good timeline, so that you have time to test things, time to have a little bit of a buffer at the end in case things don't go quite as planned. The other thing too is know your strengths and weaknesses, not only as a team, but as individuals, because when you know what someone is good at, not only is it good to just pool your resources where they're best, but it also kind of gives you an ability to see who can learn from who and what kind of pairings you can make. So when I was a rookie, I loved working with someone who's really, really good in build, because it really allowed me to watch what they would do and ask them questions about the decisions that they'd be making. And then I got really good at wiring pretty quickly. So I became the go-to wiring person. And it's always been my forte of showing people oh, well, this is how I do it. And this is a small trick that I learned, especially depending on the equipment that you have. So kind of trying to see who your best bets are for when you're no longer there. Who's going to be taking over the responsibilities you had? So I made sure that when I was leaving my last school, that the next person in charge of wiring, they knew what they were doing and they knew which equipment was available to them. And they had kind of a plan of action of how to teach the next person that would be taking over after them. So kind of having this sort of I'm not going to say contingency plan, but kind of a contingency plan, so that your school can keep participating year after year, and that you feel like you've given something not just to your year and your direct team, but that you've left sort of like a legacy. So knowing your strengths and weaknesses, knowing what other people are good at and not quite good at, so that you can make everyone better and give a good learning opportunity. And it'll also make you a better builder, because sometimes you'll realize that you have your own gaps in knowledge. Well, you'll have been doing something because someone told you that's how it's done. And then someone will ask you a question and you'll be like, you know what, I actually don't know why I do it that way. Let's look it up. Let's figure this out together. And the last one, I feel like this is a no-brainer, but always consult each other. So always ask each other where you're at. If you're not sure, instead of just jumping in on something, or not necessarily ruining somebody else's work, but kind of getting in the way of it, or, working in a redundant way where you start doing something and then another person's like, oh, but I was already on that in a different spot. So just make sure you're always keeping each other updated and just mentioning like, hey, by the way, did anyone get started on this? No? Okay, well, I'll do that today. And then if anyone has any questions about where I'm at, I'll let you know. So just keep each other updated constantly. That's what group chats are for. It goes above and beyond that just general communication of announcements and stuff, and just directly making sure that you develop links between each other. So just preparation, communication, pillars and cornerstones of building or any kind of project you'll get into. Moving forward. There we go. So choosing materials, this is going really into the cornerstones of building. So there are the three main ones that we tend to use in robotics are wood, aluminum, and steel. They have their different pros and cons. So wood, it's not aesthetically pleasing. It's not very strong and it's not very heavy, which can be a good thing and a bad thing. So the weight, sometimes you do want something that's a little bit lighter, a little bit more malleable, something that can absorb shock a little bit better. And in that case, yeah, wood is a great thing to use. It's definitely your cheapest option, and it's really easy to work with because it doesn't have that same rigidity as aluminum and steel. It's a lot easier to cut through as well. Speaking from experience, filing it down, it's not as hard as doing it with the aluminum and steel. And the environmental impact isn't as great as something like steel that cannot necessarily be recycled. So then we get into our big boy, good old steel pipes and things like that. So those aesthetically very pleasing, makes your robot look very fine-tuned, very polished. It's not as easy to work, but it's a lot stronger. So those are the things that, especially for a frame, you might consider using. It's a lot easier to weld with than something like aluminum because it makes really good joints. So it is something to consider when you're going for something that's very, very sturdy, but it's not the easiest thing to work with if you're newer and it's not as malleable. Whereas aluminum, it comes in many different things. So the example we have here is called extrusion metal. And it also comes in square piping. It comes in that sort of capital I shape that you see on the steel. There's so many different ways of, there's so many different styles of aluminum that you can use. I was personally prone to the square tubing one, not so much the extrusion metal until recently. I think it works really great. I built most of my frames out of that, a mixture of steel for just the outside parts that I really wanted solid, and then using aluminum for all of my joints and connections, because it's really easy to work with. You can either drill right through it and have a nuts and bolt system where things that you want to be a little bit more removable are perfect for that. Otherwise, you can use your self-tap screws in those and they hold really, really, really well. It looks really well, and it looks really nice. And the cool thing is that the environmental impact when it comes to aluminum, because it's recyclable, if you can find a decent recycling plant, it's not so bad. So you don't feel as guilty, and it's pretty reusable as well. I've used our tubing year after year, especially when you're going from a very long piece of metal tubing that you used for your frame, and then cutting it down where there were too many holes drilled into it, where it's kind of been weakened, and then using smaller and smaller segments for different components year after year. So those are your main materials. The next one, cardboard, I find is really good. I wouldn't use it as an actual robot building material, but for those of you who know what C.A.D is, the Sketch is Best version anyway, the cardboard aided design. So cardboard, the great thing is that for the most part, it's free. If you go to your school's, like the janitorial staff, the maintenance staff, especially in shipping, if your school has a shipping department, they'll often have a lot of cardboard just sort of being thrown into the recycling. And if you ask them, if you're really nice with them and you're like, hey, if you have like any really good boxes that you don't mind setting aside for us, we'd use them for robotics. And most of the time they'll be more than happy to help, especially if you are polite. So politeness is key on that one. And yeah, so it's really easy to find those really big pieces. It's super easy to cut and to work with. And it's one of those things that you can use just to make your prototypes, to see your spacing of things, how things will fit nicely, to see if the angles that you chose are optimal and everything like that. So I really strongly recommend. I used to do cardboard prototypes for all of my robots, and the best systems that I had were the ones that I actually checked worked first, because if you don't check, you don't know. And then you waste materials if your prototype is built with the materials you're intending to use and then it doesn't end up working out. You're putting a lot of effort in for nothing, and there's a lot of waste going on there. So cardboard, big one. Next, we'll go into basic tool safety. I am the poster child for this. So always, always, always remember that safety is a super, super important part of any project you're going to be working on, especially when tools are involved. Tools can be a wonderful, wonderful thing, but they can also be very dangerous. So one of the biggest things is misuse and improper maintenance. Tools themselves, if you're using them properly, most of the time should not be dangerous. But if they're not taken well care of, they won't be optimal. And if there's any rust, if they're not aligned properly, if they're glitching in certain ways where you have to use an incorrect protocol with them, you're going to be putting yourself at danger. You're also putting your tools at risk of being broken. They're going to get degraded much more easily. So the main things I always want you guys to consider before you start building is, are your tools in good shape? So do you see that they're rusty? Are they making weird noises? Is there like a smell coming out of your drill that you probably think it shouldn't be making, like shouldn't be having? Just check to see that they're in good condition. Make sure you're using the right tool and the right size for the job. So general rule of thumb, the smaller the blade, the better. Don't take out the full blade on your X-Acto if you only need the point, because you're only making little scoring marks into a piece of cardboard. Or if you're just, if you're cutting into a piece of wood, then don't take the super, super big blade that you don't really need for that job. Make sure that you're using right sizes for the right equipment. And make sure that it's clean and maintained. The biggest danger is that if your tools are not clean, they will get rusty, they will get slippery, they will have little glitches in them that'll make them very volatile. So make sure that your tools, of course, unplugged, especially if it's something that's a power tool. Make sure that they're staying cleaned. Make sure that they're not slippery, especially if you're using grease at any point. I've seen it happen where someone had a drill bit that had too much grease on it and it slipped right off of a piece of aluminum and went through his finger. So be careful of those things. They're very, very dangerous if they're not used in the correct manner. Pointy tools always carry down. That's not just in shop, but at the competition as well. Always know where the points are, and as much as possible, not towards other people. Wear appropriate clothing. That's just a big one. Seems like a no-brainer, but if you're working with heavy things, make sure that your toes have either steel caps or just sturdy boots that nothing is going to pierce through it or crush your toes. If you are using something that you need to be wearing gloves for, wear your gloves. Safety goggles are your best friend. Anytime there's a power tool being used, even if it's just a drill, I strongly recommend the bare minimum is wearing your safety goggles. Those are big time lifesavers. I can't tell you the amount of accidents can be avoided just by wearing your safety goggles alone. And make sure that you keep anything extra off of the floor. Anything that you don't need to be using should be put away, because anything can become a hazard if you're not paying attention to it. And if you're not using it immediately, chances are it's left your mind. So just keep your workspace as clean as possible. Don't have things lying around. It's going to be good for the tools. It's good for you. It's good for your teammates too, because when you have a long day, sometimes you don't remember to clean up specific things. So if you're doing it as you go, you have less of a job at the end of the day, and your teammates know where everything is when they come in to take over for you. So small little tips about tool safety. The other thing too is, we can't, as much as we try to prevent injuries, sometimes they're inevitable. So I strongly recommend just looking over the slide quickly. Make sure that you have a first aid kit in your robotics lab, wherever you are, whatever workspace you have. Always have some sort of first aid kit, and have someone who knows how to use it as well. If nobody does know how to use it, then ask one of your teachers, if possible, to give you that information. Have someone that is the key person to make sure that they know how to take care of any small injuries that might occur. And know that if there are big injuries, hospitals are your first option, but hopefully we'll never get there. So during construction, now we'll get to the real stuff. So always consider the order of assembly. Never try to put things together that might block your future work. So if you're building something that's really, really complex that you know you're going to have trouble disassembling or getting through, make sure that all the stuff on the inside is being taken care of before you case it off. So an example of this is if you're building a frame for your robot that you know is very much cage-like, or if you have to put a panel over something, make sure everything inside of that panel is fine-tuned, tested, and that especially for the wiring stuff, people tend to forget wiring and they leave it till the end. So make sure that your wiring is done so that when you do block off those sections, there's a lot less taking things off, putting things back together, and then being blocked and not having the right space to like get your drill in there where you want it to be. So just always consider the order that you do things in and try to make it as logical as you can. The next thing would be to preserve and reuse your materials as much as possible. Again, there is a big environmental toll to doing anything related to engineering and construction. So at the end of your season, as much as possible, check what the integrity of the materials you used were and try to find a way to give them that second life if possible at all. Also, one thing that some teams don't consider is cost versus durability. So sometimes it's good to get that cheap thing that you'll just be using for 1 year because you know you'll only be using it for a year. But for other things that, especially when it comes to tools and bulk materials, try to use them like motors or gears, things that you know you can reuse that you're not necessarily drilling into or modifying directly. Try to get the good quality ones that you're not going to have to just throw out after 1 year of use, or the ones that won't break as easily. The next thing is test all the time as you're going along. So as much as possible, if you finish one step or one component, really try to see, okay, now is it working the way it was intended to work? If you have game pieces in the game that you're playing, try to test them out with those game pieces. Try to see if they're hitting their marks. Try to see if your variables aren't as controlled. So let's see if I'm not perfectly aimed on this particular marker. If I'm slightly off, what are the chances that I can readjust and then still hit my target that I want to be getting? So test as you go, see what your limitations are, and it'll kind of prevent you from having to completely destroy your robot later because you realize, oh no, there's one thing that's not working. Now I need to take everything apart. So solve your problem sooner rather than later, especially if it comes down to a design issue. If you realize it early on in the construction process that something's just not working, it'll give you more time to think about a better alternative, and you won't end up with something that's sort of thrown together at the last second at the competition. And the last thing to really consider is using your resources. So find tutorials about the best way to do something. Anything that you're doing, chances are it's been done in some capacity before. So try to find some keywords that you can use to sort of figure out what kind of videos are available to you, especially on YouTube. You can ask your mentors, you can ask past participants, and of course, your best friends, the CRC. We're always there to answer your questions. If ever you have very specific questions related to how to do something, we won't give you all of the answers, but we'll definitely give you the right questions, and we'll point you towards good resources to be able to figure things out on your own a little bit more. And so, yeah, find as many resources as you can and definitely use them. A good engineer is one that knows how to find their answers, not just one that knows the answers to begin with. Next thing, biggest motto ever, measure twice, cut once. So a lot of us have this habit of diving headfirst into projects, especially because we get really eager. We think we know what we're doing, but when you go too quickly, you tend to miss small things that can be solved just by going over things one more time. You've guaranteed had those teachers in your life who, if you finish your test early, they'll be like, okay, well, why don't you just sit down and go over it one more time? You might catch something that you missed the first time. And it's so true. Any project you do, always measure twice, cut once. By default in construction and robotics, I tend to go with 3 key points along those lines. So bigger pieces have bigger costs. This is just a general rule. The big pieces of your frame, so the ones that are making up the length, the width, any big components that are the joints, if they're not cut to the proper lengths, then you're probably going to be wasting a lot more material, especially if you cut them too short. Because if you cut them too long, then yeah, you can cut up that little extra bit. But if they're too short, and you try to use it anyway, it could alter the design entirely. It could make your frame weaker than you wanted it to be. Or if you try to add on little pieces to make it better, it's not going to be as good as if you had cut it to the right length to begin with. And if you do have to redo that whole piece because it's so much bigger, you're wasting a lot more material. So always measure again. Some things that I didn't know when I first started is when you think like, oh, okay, I have this 12 this 12-foot piece of aluminum piping, I need 3 4-foot lengths. Perfect. I have that. No, you do not. Because you have to take that blade width into account. So the blade that's cutting into your aluminum is going to be taking up a certain amount of space. So the thinner your blade, the better it is. But again, it won't be quite as strong. So if you really want to get like the most out of your fit, just consider what thickness of blade that you're using and count that into your whole piece. And another thing that I was taught a little bit later was note the side of your line. A lot of us use Sharpies, and that's a very thick line. And that thick line, depending on if you're cutting straight in the middle, straight to the side, or whatever side of it you're cutting on, it can make a huge difference in how things are going to fit, especially if they need to be perfectly fit to each other or aligned with each other. So note which side of the line you measured from and which side you should be cutting on, where you should be aligning that blade of your saw. So that will give you the best final product. It'll be the cleanest one. Second general rule, press fit is best fit. So when it comes to something like a frame, you want very low mechanical tolerance. So what that means is whatever measurement you had originally put in your design, the cut that you make should be as close to that original measurement as possible. Because if you're off by, let's say, 2 or 3 centimeters, it doesn't seem like a big deal in theory, but when you get to putting things together, it'll strain your material if you try to force it and bend it into the place where it's supposed to go. So one thing that I learned when I was first starting out and I didn't quite have that keen eye for getting the cut right the first time, even if it does waste a little bit of material, try cutting slightly bigger than your original measurement and then file down as you go, especially when you're not sure exactly how it's supposed to fit, or if the first piece you cut wasn't exactly what you wanted according to your design. And then the last big point is start big and then work your way down. So the best way to make sure that you're not repeating components or having to adjust things all over again is if you do your bigger parts of the frame first, because they have that big variability and you don't want to be wasting material. If you get the biggest parts done, you have a better idea of how the rest of your things are going to fit into place and if any design adjustments need to be made. One thing I noticed in especially newer designers is that they don't necessarily take into account the width of materials into account when they're making their designs. So if you say, oh, well, I need 12 inches to make this specific component, they're not taking into account that the material that they're going to be using to hold it into place is taking up an extra inch or 2 inches here or there. And then when they go to put it on the final product, they're like, ooh, this doesn't fit. So always make your bigger parts first and then try to see how you can size the rest down to make it fit into place as much as possible, especially because we do have size restrictions in the CRC regulations for the robots. So if you make your bigger stuff first, then everything else will automatically fit into place. That way you're working inside of a restraint instead of having to make something and then you realize you can't go any further and now you're stuck. We often also forget about the linking details. So when you have 2 components that you're trying to put together, you don't forget, they don't just necessarily sit one on top of the other. So think about how you're going to be attaching things. And if on the bigger parts of your frame, you don't have anywhere to attach things, then think about adding an extra bar, thinking about adding an extra link where you can put your components that they'll rest in a comfortable way, where they'll rest in a way that will be secure and that they'll be able to function without being restricted. So especially in low tolerance systems, big example of that would be tank treads. So because I'm not sure for those of you who were there last week in design, tank treads, they really require that low tolerance so that they don't start skipping or that they don't get pulled to a point where they're going to break if they get any more tension. So make sure that whatever you designed will still fit that system and adjust where you're needed in that case. So build your frame first. Build your alignments for the bearings that are going to go onto it, then measure out the tread size that you're going to be needing. Whereas if you do your treads first, then you drill your holes, then you realize, uh-oh, I miscalculated that. Now I'm going to have to go back and recut my treads or remeasure them or whatever the case may be. So just be careful of those small things. Next is find your weakness. So big thing, test as you go. We already went over that, but definitely test the strength and resilience of your frame. Forgot me on that one, but test the resilience of your frame as you go. Make sure it can handle the competition. If you trying to wiggle it with your hands or just like, 2 people pulling on it breaks it, then it probably wasn't ready for the competition to begin with, especially if your competition is a little bit more, if you might hit a rail, if you might jostle it a little bit. So test it out. If your robot can't handle the small stuff, it definitely won't handle the big stuff. And then if you notice that, ooh, it's wobbling in this specific spot, or yeah, you know what, that one screw that we put in, not quite enough. Where can we put another one? Or what can we do? Maybe add a bracket, maybe add some sort of transverse bar that will keep the two pieces together a little bit more in a little bit more of a sturdy way. Diagonal forces, best ones. So try to figure out where you can add certain things or how you can make things stronger on your frame to make sure that it can handle the roughness of the competition. The next thing is load weight on your system or on your drivetrain to kind of mimic the weight of the systems that'll be on it. This is the best way to make sure that the motors you chose are compatible with the weight requirement and the force that you're going to need, especially for those of you who want to make a fast robot. We tend to say, oh, you know what, this won't weigh that much or that won't weigh that much, but then we don't consider the weight of the motors, the weight of adding that many screws or this many, you know, the tape, the this, the that. So we underestimate the force that's needed of our motors. And one thing that we used to do is we build our systems a little bit. We kind of sort of throw everything that we need for a system onto a scale, see how much it weighed, and then we'd add weights to our drivetrain and see if it could go with it. And at some point we knew we were going to have a very heavy robot. So we tried to see how many of our teammates we could put onto our drivetrain before it stopped being able to roll at the speed we wanted. So we would actually stand on our robot and test out the frame and the drive system that way. And it's also kind of fun. It makes for really funny videos, especially for your website and things like that. So it could lead to some pretty fun team building moments as well. The biggest weaknesses that I've always noticed when building robots are the mainframe joints wobbling. So when you're building that like rectangle shape, or when you're building the things that are going to go onto your wheels, just sort of try to jiggle them apart from each other and try to wobble them to see if there's any space, if there's any sort of motion that's happening, or if it's really sturdy. If it's not sturdy, see if there's a screw that's loose somewhere. See if you'd be better off putting a nut and a bolt. See if using T brackets or L brackets on those joints could help to make sure that there is no movement between the joints of your mainframe, so that it's a little bit more sturdy. It can handle impact a little bit better, and there's no risk of things just accidentally falling off. And then if your mainframe breaks, then inevitably the rest of your robot crumbles down. So that has to be as solid as you can get it. Make sure that your motors are sufficient. So like I said, testing them out, adding weight to your system and testing your drive. See if your motors have enough juice. And if they don't, switch them out early, especially if they're in a harder to reach location because of the design that you made for your robot. The less you have to switch out your motors, the better it'll be for you. Check for the misaligned wheels or motors. So again, sometimes when we design things, we have like such a low mechanical tolerance that when you put your motor onto a part of the frame and then you try to attach your wheel, especially if it was something like a tank system, then you realize, oh no, they're not quite aligned the way they're supposed to be, or something's off here, it's not driving straight. So test those things. So test the way that you're driving, if everything fits into place when it's put together. And if not, try to find a way, add a tensioner on a tank system. See if there's a way that you can sort of move your motor to a specific side, or see if you have to just altogether change it up. Usually a bracket or two can help to solve that problem. Testing it beforehand, I used to tape down my motors before I would drill them into place so that I didn't have to remove the integrity of my frame, but I could see exactly where I needed them. So I taped them really hard into place. And then the moment you're done, you just, even before you remove the tape, drill them into place and then take the tape off. That way you know that they're going to be properly aligned. And then the next point is the lack of central reinforcement leading to the bowl effect. So a lot of frames that I've seen in the past, they are good on the outside, but they forget to take into account that most of the weight of your robot is going to be on the middle. And so what ends up happening is, especially if you have like a plate of some sort that's holding all of your systems into place, all the weight going down in the middle is going to make your robot bend in the middle and make it look kind of like a bowl. And you don't want that, because the more impact it's going to take, especially if your robot is bumping around, if it jumps off of something, whatever the case may be, all of that weight is coming down in the middle, and it could risk breaking your frame, especially lengthwise. So just be careful of that and see if you can add maybe a bar or a joint here or there in the middle to make sure that the bowl effect is not happening and that you have a very like leveled robot the way that you intended it to be. And the last one, and it's something that I've noticed a lot in teams who do things separately. So teams who say, okay, you take care of doing the drivetrain, I'll take care of this system, I'll take care of that system, is when there's that lack of communication, the frame tends to be lacking in space for anchoring the components. So make sure that you have enough width of your materials that you're using, or enough joints that when you have to put your components on, you've got somewhere to anchor it. That's not just adding on to like, oh, okay, let's just add a little bar here or add a little bar there and see if it'll kind of work. Like, no, think about those things beforehand. Make sure that your frame is ready to handle the components that are being put onto it in a way that is conducive to them working. All right. Any questions so far? I know I'm going kind of quickly over here. No? Okay. All right, perfect. So we'll keep going. My favorite topic. So like I said, I was one of the wiring junkies of my team. So wire as you go, never ever leave your wiring till the end. Some people are like, oh, well, there's just so much to think about when it comes to wiring. So I'm just going to leave it for the last person, and then they can take care of it all at once, and then everything will be perfect. That's not quite how it works. So because of how hard it is to access certain things, and because of how tricky wiring can be, the worst thing you can do is leave it to the end where you're left with the bare minimum, and then you're trying to figure out, okay, oh no, where am I going to anchor all of these wires? How are they going to pass through without getting spliced in two or getting pulled apart or getting in the way of other things? So think about your wiring when you're making your frame. Think about where you can run the wires along the frame so that you have as much of your robot covered as possible. My best tips are add terminals. So these terminal blocks that you see on the lower left over here, that's a terminal block. My best friend, I use them at different points in the frame for easy connections so that I can add or remove things, especially in case specific sections of wire break. That way you don't have to cut an entire wire off or cut a section and then weaken your wire. You can just switch them out. So switching out wires using terminal blocks is one of the best things that you could possibly do. It also helps in labeling, because the more terminal blocks you have, if you're labeling your wires with little pieces of tape at the beginnings and end of each wire, you know exactly what they're for. And the more of those you have, the easier it is. If something goes wrong in your motor function, you can trace it back way more easily if you have more terminal blocks, because you can test the current or the voltage that's being delivered at each part of each terminal block, and then you can determine where the problem is to see if there's a connectivity issue. Next thing is add cable clamps. So this thing in the middle, these little things I'm sure you've seen lying around your workspace, and that at first you didn't quite know what they were for because they look like weird ducks. They're your best friend because they're going to keep your wires out of your way. There are different versions of it. I like the plastic ones just because they are flexible. They let your wires move a little bit so they're not putting too much pressure. And because of this little gap, you can actually adjust, like you don't have to make them press fit with each other. You can give them a little bit more room if you have more wires bundled in there to not be so press fit on them. And they're also really cheap. So getting the plastic ones is a really good idea, especially for doing robots year after year. They keep everything out of the way. They prevent your wires from getting pulled on by moving components and from just hanging around anywhere and getting yanked on. They also keep them out of your way while you're working on the robot. So even if you don't think there'll be a problem later, it'll also keep your wires nice and organized to make sure that, again, with the terminal block, you could trace things back a little bit more easily. That way you're not just left with a pile of wires on your robot that are kind of just a mishmash of things. And wherever possible, try to reduce the amount of wires that you have. So the less wires you have, the less chance that one of them something is going to go wrong with them. So parallel is always better than series. This is something that you definitely be better off going on YouTube and seeing what the big differences are between parallel and series. The one thing I will say is, for those of you who know about old school Christmas trees, those lights were in series, where if one of the lights went out, because the positive from one thing was connected to the negative of the other, that way the current was just going in one straight line through every single component. If one single thing breaks, everything breaks. Whereas a parallel circuit, so this is the one we have over here, where if these red wires are all positive, so this is coming from the positive terminal of your battery, and then it's going to two different systems, and then you have a matching one coming back. So two coming back from the negative, going to the negative of your battery. That is the best possible thing, because if this wire breaks, the other one can still have current from your battery. The only time it becomes a problem is when the wire coming directly from the battery breaks, but in that case, it would have been a problem regardless, because then it's the one coming from your battery that's broken. So this is a good system to have. I used to pile on a few to make sure that, okay, now I have all of my positive wires going directly to this one. Perfect. This is a positive wire. Good. That's all it needed to be labeled. And then it's a positive wire leading to, let's say this one's for my wheels, this one's for my claw. perfect. So I'd write claw here and then wheel there. And then over here, I'd write claw and wheel, going all the way to the next part of it, claw and wheel. And I know what's controlling what, and you're reducing the amount of wires going through your robot. This I'm just going to go over very quickly. It's about the gauges. It's not important that you remember this diagram. This diagram is something that if you go into electrical engineering or if you want to be an electrician later on, it's going to be something that'll be useful to you. But in general, the bigger the number of your gauge, the smaller the wire is. So for instance, a 22 gauge is bigger than a 10 gauge. Okay, a 10 gauge is smaller, sorry. So the bigger the wire, the bigger the number, the smaller the wire. So a 22 gauge is really, really thin, whereas a 10 is very thick. So it's kind of the opposite of what you would assume it would be. The bigger the wire is, so the smaller the number, the more current it can handle going through it. Whereas if you want it to handle smaller charges, then you can go with a smaller wire. So the low power items, anything that you're doing on your VEX motors, you can do with an 18 to 22. They're a little bit easier to work with. They don't get in your way so much. Well, they're not easier to work with, but they're easier to hide away, is more my point. When it comes to the 10 to 14 gauge, that's your 12 volts. So anything that's going into your big battery, definitely go with the 10 to 14. If you use a too small wire on something, then the odds of it burning out are very, very high. So make sure you use, if you're ever doubting it, use a slightly bigger wire. Maybe the amperage going through will decrease a bit. You're not going to get the same juice that you want, but at least you're not risking it burning out entirely. Choosing the ways to connect your electrical components. So the gold standard, of course, is soldering when you don't want it to move. So if you're doing electronics, like you see in the top picture here, of course, if you're doing a circuit board, there's no other way to make sure that things stay into place than soldering. That is the permanent connection. That is the best way. If you get really, really good at soldering, they are also very slim connections. So they're not taking up a lot of extra bulky space. They're a lot easier to manipulate. And if you're able to be really, really good at soldering, it's probably your best bet for those permanent connections that you want. The cons for soldering are that the wire gets stiffened. It's more prone to cracking and breaking. This is especially if your technique is not perfected. If you're very, very good at soldering, you're not going to risk getting that cold joint that's going to make your wire snap as easily, but it's still a little bit more complicated. It's not as protected as a crimp would be, which I'll show you in a second. Flux paste can sometimes be corrosive. It can cause certain problems over time. So just get good condition, like good quality solder, and make sure you use flux. Again, videos on YouTube are the best way to learn how to solder correctly, especially depending on what kind of soldering you're going to be doing, what materials you have, and all of that. And speaking from experience, everyone has their little tips and tricks for how to solder correctly. None of them are necessarily the best one. It's just some are inherently not correct, but you find something that works for you, and usually that's the best one to go with. Another thing is that it does take longer and it requires more equipment. So you have to be safe with soldering. It is a very, very hot tool, and it's very easy to get wrong or to hurt yourself with, and it does take some time. So this is the one that you do when you have the time and you want to make a lasting connection. Crimping. So this is the one that's quick and easy. Anytime, especially if you're at the competition, don't waste time with soldering. If you just need to get a wire back onto another wire, crimp it together. The best way to make sure that it's a good connection is to have the proper tools. So if you do not use a good crimping tool, if you use those cheap all-in-one kind of things, your crimp is probably just going to fall off. So make sure that you do it correctly. So this is what it looks like when you keep the sleeve. So that plastic coating, when it stays on, this is what it should look like. And then you could put heat shrink over it if you want, but you don't necessarily need to. If this plastic thing gets removed for whatever reason, this is what you end up with. This little metal piece that gets bent around your wires so that it creates a very, very tight fit. And it's so gripped onto those copper wires that they've bonded into place. So it's considered a cold weld for that reason. It makes the wires more reusable in a sense and exchangeable because of these little ends. If you solder them together, then you can no longer detach them without breaking the wires. Whereas this one allows you to make smaller segments of wires and then connect them either with specific adapters or using these. This is where it would go onto your terminal block. So you would basically put this over your terminal block, and then the screw would go into this hole. And then because the screw is made of metal, the terminal block is metal, and this part is metal, everything conducts. And so everything is leading to a good current. Again, the big con is that if you have cheap tools, it'll give you a bad connection, and it's often bulkier than good solder. So personally, I've never been a fan of using crimps on anything that I know needs to be permanent. So if it's a direct motor connection, I wouldn't use a crimp for that, or even just a general connector. I like to solder my motors directly and then use a crimp to connect things. But again, sometimes crimps, especially if it's not the ones that lead to a terminal block, if it's just the direct connectors, they tend to pull apart if they get pulled too easily. Next up, we've got how to avoid making bad connections. So like I said, avoid the all-in-one or the plier type tools. So don't use these ones. These are just good for stripping. Use the good ones as much as possible. If you have a good set, use them. Of course, if you do have only these kinds of tools, then you can still do your crimps. You just have to be a lot more careful and definitely test them before you put them onto your robot. So once you're done with the crimp, just give it a quick yank. And if it ends up coming apart, then your crimp wasn't good to begin with, and you just need to restart. That's all. So you just reset, you cut a little bit more of your wire, strip it, and put a new crimp on. You cannot reuse crimps either. Once they've been crimped, they will not go back to their original shape. So if you've used it once, you have to toss it and use a new one. Next up, last thing in avoiding making bad connections, just make sure that you use the appropriate size. So if you use a crimp connect that's too big on a specific wire, so if I use these yellow ones on a high gauge, so like 1822, where it's a very tiny, tiny wire, it won't fit correctly no matter how well I try to crimp it, because it's just inherently too big. There's too much dead space that I cannot remove just through crimping it without completely ruining the crimp itself. So use the right crimp for the right size wire. There's guides like this all over the internet. If ever you forget, you don't need to memorize this. Just look up, which color crimp for this gauge wire. And it's pretty standard universal that yellow is for the thicker wires, blue is for medium, so 16, 14, and then red is for your 22. For your purposes, you're probably only going to end up using yellow and red, because we don't really use the blue crimps, because we don't really use anything for the 16 to 14 gauge. Again, red is for your BEX connection, your smaller 5-volt motors. Yellow is for anything connected to your 12-volt. And then make sure that your cable is well stripped and that there's no strands that are missing or cut. So if you can see over here, like half the strands have been cut through. So your wire, instead of being something like a 10 gauge, is now going to a 12. So it's a little bit smaller than what you would originally planned on it being. And last thing on avoiding failing connections is use heat shrink. That is definitely one of your friends. It'll keep things together so much more nicely. I love heat shrink. It's basically a little sleeve that you put over your connection. And then using a lighter or a heat source, you just sort of pass the heat over it, and then it shrinks up into place exactly where you want it and takes the shape of your wires. So it prevents things from sort of getting in the way of them, or it also hardens around it, so it prevents it from bending too much. Support your wires and protect them as much as possible. So use these little clamps, use the zip ties, use anything you can to make sure that they're not being pulled on by anything, even each other. And make sure that your cables always have extra length for repairs. So again, that's where these little ties will come into place. If you can, just sort of coil your wires just a little bit in case you do need to cut them. Or, like I said, use a few more terminal bars if you have them lying around, and make segments of wires so that you can swap them out pretty easily, and always have those backup segments ready to go. Always test your connections, whether they're crimped or soldered. So make sure that it's a tight tug. Like, just don't like yank it to an extreme. Don't like completely test it. Don't play tug of war with it, but give it a quick, like, very dry tug, and just to see if it'll hold together. If it does, it should be fine, and you can put it onto your robot. So always test your things out before you add them. So that's about it for things that related to construction. Like I said, with anything that comes to robot construction, it's really dependent on your design. So if you have more specific questions, then you can always ask us. You can look them up on YouTube. I used to use YouTube videos all the time. Even sometimes you might just not get your direct answer, but you'll get something close enough that'll inspire you to come up with something new, or to look at things from a different angle. So feel free to ask us questions. If you guys have any questions now, I am definitely available to answer them. So you can write them in the chat if you have any.